Okay, here we go. Bowen, Chisholm, Madeline Christian, Contreras, Curl, Eater, Tom, Hand, Lee, Linders, McClure, Navarro, Quintero, Ramos. Okay. Rodriguez, Carissa. And Rodriguez, Giovanni. So I got both of you. Silvestri, Simpson, Torque, Von Henkel, and Walker, and Wilson. Beautiful. Okay. Anybody so far having any questions or problems on the quizzes for Chapter 3? Chapter 2? Chapter 1? I know it's too late. I still will answer questions. Okay. Folks are generally doing fairly well on the quizzes and normally doing it with only 1 or 2 takes. If you're struggling through that, if you're struggling through the quizzes and you're kind of going, okay, I'm retaking, your grade's going up, but you're not feeling comfortable with the material, let me know. Again, you don't have to let me know if you're in class. 206 Old Main, I'm there a lot. And if I'm not there, just make an appointment with Emily. And I'm happy to sit down with you and go through it. I just know that we're about to hit the steep slope, and I want to make sure that you guys are in good position going forward. We started on time value of money last class briefly, and I'll ask the question, give me my mantra. Anybody remember my mantra from the end of last class? Because I think, as I said, I'm going to build a PowerPoint. I think I'm going to start with it for every class for the remainder of the semester. So anybody remember what I had said? Yes, sir.
Time value, money has a time value.
Time has a money value, money has a time value.
That's the cost of interest.
Yes, sir.
Assets equal expected future cash flows.
Yeah, so that's where I was headed to. The value of any financial asset, arguably the value of any asset analyzed in a financial frame. So that could include rental housing, that could include your house, your car. The value of that asset is equal to the expected future cash flows discounted at an interest rate, and that interest rate is a measure of risk. So it's the risk that those cash flows won't show up. And if you can understand that concept, that frame for net present value or for how finance works or what an asset is, most of what we're going to spend the rest of the semester talking about is how do I determine the expected future cash flows? How do I determine the risk as expressed as an interest rate? How do I put those two things together and either come up with a value or make a decision between multiple choices as to which one is going to be financially the most expedient choice to make? So I will repeat this over and over again until you're tired of hearing it. You'll probably see a question on the final exam that says, like, explain the definition of an asset in a financial frame, and then you can just regurgitate this. And if you can remember this piece, the rest of finance is just the math. So we're going to talk time value of money. Expect next week, as I will remind you, no class next Friday. We'll have class Monday, Wednesday. Expect that Monday and Wednesday, we're going to be doing some problems and some workups on the computers in here so that you get comfortable with the Excel and get comfortable with the Excel formats and formulas that you're going to need to use. And I'll give you some handy dandy tips on how to kind of set up an Excel spreadsheet on Monday so that you're ready to go for all the work that's going to come kind of follow on. So take a little bit of time this weekend if you haven't already. If you have Excel, fuddle around in there, particularly under the financial formulas. So you go to the formulas tab and you'll see financial formulas. Take a look at those various financial formulas. Take a look at the Highline Community College videos that are on Moodle. Start getting familiar with present value, future value, number of periods, payment calculations, and we're going to start diving into that next week. Today, I'm going to talk more the theory of time value of money. We're going to walk through some slides, and it's going to tie back to the book. But I want to remind you of two things, not that probably you have forgotten. The first one is I don't expect you to memorize formulas in here. You're going to see a bunch of formulas in here, and it's, the summation of X, and you got exponents, and it's stack on top of stack on top of stack things. And I don't expect you to memorize formulas because we have tools like Excel that do that for us. So don't get spun up as we're going through things today and as you're going through the book that you're going to have to memorize the formulas. The second thing is really, as we look at these formulas, I want to try and point out to you the principles behind them and why they're there, and we'll ask those questions. Why do you think it's set up this way? I want you to understand the components that are going into it, not, you're not going to have to write a dissertation on why this formula is structured that way. It's more to set the stage going forward so you understand the theory behind the practice in finance. So time value of money, we have talked right along. Time has money value, money has a time value. And in the time value of money, we're really taking a look at how much is money worth today, or how much is a payment stream worth today if it's coming to me in the future. And it doesn't matter how far in the future. And we're going to talk about perpetuities, where essentially we could say if someone will give you $1 every day for the rest of your life, or $1 every day for forever until the earth ends, we could calculate what that value is, because as we go out, the value of each dollar, $1 to you in a million years is not worth all that much. You're not going to pay that much for that right today, nor will your kids, nor your grandkids, nor your great-grandkids. And so the value of that, everything kind of starts to go to zero, so we can calculate the value of perpetuities. The principles used to value cash payoffs are time value of money. We're looking at how do I value something in the future today. This is critically important, the second one, that's why it's in italics. And it's something that it doesn't matter whether we're doing time value of money or whether we're doing analysis like we did with Unilite, where we're looking at 2015, 2016. When you're doing ratio analysis, dollar amounts from different time periods can't be directly compared. So it should never be compared. But they should be compared only after they've been stated in equal dollars, such as December 31st of a particular year, or we've taken a look at the impacts of things like inflation. So I'm going to ask a question. If I were to buy a house in Seattle 15 years ago, and it was $200,000 for that house, and I'm now buying that same house, or I'm going to sell that house, and I'm going to sell it for $700,000 today, and I say, was the house worth more 15 years ago, or is it worth more today? How do you answer that question?
How badly do you need it?
How badly do you need the money? That's a different question. But if I said, look, it was worth $200,000 15 years ago, and it's worth $700,000 today.
What was your $250,000 worth today that you spent then, depending on inflation and interest rates?
So everybody hear that? What was the $250,000 or $200,000 really worth 15 years ago? What could I buy for that $200,000 15 years ago? Could I buy, a new Rolls Royce? And the new Rolls Royce now is, $400,000, so the house is worth more. What was the inflation rate in a basket of goods like the Consumer Price Index back 15 years ago? What is it today? And then you can really start to compare. Once you kind of account for inflation and the loss of purchasing power over time, you can then go, okay, that $200,000 was worth, if I take the future value of that at a rate of, inflation was 3.5%, and I calculate that compounded over 15 years, the value of that house should be $575,000. It's now worth $700,000. So there's been a gain in wealth. Or you could say that $200,000 house became $800,000. I've got $700,000 I could sell it for. I actually had a loss in wealth relative to what I could have invested in that basket of goods back in 15 years ago. So you can't compare those two dollar values without putting them in a common frame, without accounting for the fact that it's at different time periods and there's time is elapsing between the receipt of cash today and a receipt or payment of cash years ago. And so as a result, you've got to go through a time value of money calculation. Dollars from different time periods have opportunity costs. So if you're looking 15 years ago, you could have invested in certain stocks, bonds, and other things that could have grown that money significantly faster than that house or significantly slower, or could have caused it to diminish. You could have bought the Rolls Royce for $250,000 15 years ago, and it's worth $50,000 today because it's declined in value. So you've got opportunity costs that you need to look at, and that's also stated in terms of interest. Because that stock you buy, you would expect potentially a higher return because it's riskier than a house. And if you put that money in a CD where there's really hardly any risk at all, the return that you're going to expect on that should be lower than you would expect on a house and lower than you would expect on the stock. And what we're going to do is spend a significant amount of time talking about what that risk looks like and how to start calculating those differences. This is a typical time value of money problem. And if you think about how to set this up, we're going to pull pieces of data. They're all word problems, or almost all word problems. We're going to try and pull pieces of data out of the word problems and set them up so that, and we'll walk through this in Excel on Monday, set them up in a table so that you've got an opportunity to link your formulas through and make the changes. So at 10% opportunity cost rate, which is better? Receiving $700 today or $935 in 3 years? Anybody want to hazard a guess? Yes, sir. $935, why? So you're saying I want $935 because I'm getting 10% interest on money over that period of time. Yes or no? Is that the thought process? Okay. So what if I frame it this way? You got $700. I'm not saying if he's right or wrong. I'm just going to frame it a little differently. You got $700 today. and I say you can take that $700 and you can invest it at 10%, or I'll guarantee you $935 in 3 years. Which choice do you make? Yes, ma'am.
I go with $935 because I didn't put the value up thing on itself and it's worth $2.48 more.
Okay, you've jumped me. Yes, sir.
What did you say?
Oh, you don't want to hear what she said. I want to hear what you said.
He said it was right.
You made $2.48 compared to your second.
And so at 10% cost, that's how much they're taking away?
No.
No, it's not taking away.
It's an operating, so when you see things like opportunity cost, that's essentially the interest rate. And so the way I want you to think about this, and the reason we're going to talk through these word problems is because they frame them, they use different words to say the same thing. And we're going to find that you really only have a couple pieces of the puzzle that you need to pull out of these word problems to be able to calculate it. 10% opportunity cost is essentially saying that's the interest rate you're going to use to evaluate your decision. And so you've got a choice, and that's why I framed it a little differently. So you can take $700 today and invest it at 10% for 3 years. And are you going to be ahead by just saying, no, I'll take $935? Or are you going to be in 3 years? Or are you going to be further ahead by going, no, give me the $700 now, I'm going to invest it at 10%, and I'm going to be further ahead? That's really what this question is asking.
I don't take the 700.
You'll take the 700, and you'll take the 935.
You just lost
Just think about it. If you're taking 935 in 3 years, you're splitting it up in 3 years.
No, you're not.
You're taking 10%
He's not
of what you're splitting up that
He's
year.
not saying recognize revenue.
How much?
How recognize revenue over 3 years.
Using $3.
So yeah, you're losing. We'll go through the math, but we just had a good question come up. How badly do you need the $700? So how do you think we quantify how badly I need $700? What number up there?
10%.
The 10%.
Okay, the thing is though, if you need that money today, you're not investing it at 10% and getting.
Well, that's your opportunity.
You're just using
Yeah.
it right away. You're investing it all.
Well,
It's a totally different thing.
Yeah, and so what you're saying, or what we're saying, without trying to get too detailed, because I can come up with a hypothetical for everything, is we factored in the risk of not having that money. The cost, we've got to get paid to not have that money today. And so we say we want at least a 10% return on that money to not take it today. If I really need it today, I might say this needs to be 20% or 30% or 40% because I need that money today. But if the number gets high enough, if someone goes, okay, it's, instead of 700 today, I'll give you 2,100 in 3 years. You go, okay, well, maybe I'll figure out the $700 somewhere else. So that's the way that the interest rate is the way that we mathematically begin to take all those components, which we view as risk. That's how we view it as risk, the risk of not having it today. And that risk may be that I get my legs bashed in by some, loan shark down the street. So I'm willing to take that risk for a high enough return. We try and take all those subjective things and turn them into a math problem, and that's the 10%. So let's walk through this one on a timeline. So we say, okay, to answer the question, we got to evaluate cash payouts, so they're stated in dollars in the same time period. So we want to know what's the value of $935 in the future, $700 today, and you could do it one of two ways. You could either go, what's the future value of $700 at 10%? Or what's the present value of $935 at 10%? I find it easy, although cumbersome, to use, especially if I'm trying to work through a word problem, to use this timeline. And basically go, here's my years. So year 0 is right now. This is the end of the first year, the end of the second year, it's the end of the third year. The R, the rate of return, is 10% in each year. And so you go, okay, I've got, and you'll see why some of these things are important as we go through the solving of it. So you go, okay, I got 3 years, which creates, for our purposes, 4 measurement points. The 0 point today, the end of the first year, the end of the second year, and the end of the third year. You're generally going to have a +1 on the number of years or number of periods, because you've got to have 0, which is the present day. So which way do you think these are going to give you any different answers? They shouldn't. The math is that you're either going one direction or the other. And in a lot of cases, it's a question of which way do you conceptualize? Which way do you feel most comfortable trying to analyze this problem? So present value says the beginning amount that can be invested. So that's this. The future value is what we're trying to calculate. So here's how you look at it from a timeline. 700 at 10%. What's that going to give us here? 770. Then you just go through 770 at 10%. It's going to give you 847. And then you're going to go through that same calculation again. Yep. We'll come back to the math. There's a few things that, as you build these problems, there's some definitions which are important. Lump sum, which is a single payment that occurs today or some point in the future. So you're saying, okay, this is going to happen once. That's generally referred to as a lump sum in most of these problems, but you'll see some other things like you start with a principal amount of X. The toughest part, once the math isn't going to be hard, the Excel is going to be pretty easy once you get into it. The toughest part is going to be pulling the threads out of the word problems and going, okay, how do these factor into the equation? An annuity is a contract, technically. Is a contract that says we're going to make payments to you over a certain period of time. Normally, they're like retirement payments. So you got a payment, we're going to pay you every month. Social Security is an annuity. We're going to pay you every month on the first of the month a certain amount of money. For time value of money purposes, the annuity says it's the same amount. Social Security goes up every year. It's tougher to calculate the annuity. We're not going to get into those kind of rolling annuities or changing annuities. For us, annuities are considered the same payment in every period. Uneven cash flows are different payments in different periods. So you've got an annuity and you've got uneven cash flows. The principle is going to be the same. The method of calculation in Excel is going to be a little bit different. A lot of times we're going to be having problems where you've got two of these. You've got a lump sum and an annuity. You've got a lump sum and uneven cash flows, and you're being asked to compare two values. Choose one. Which one is more valuable? The future value, as we had calculated through this, we started walking through it. It's add the interest. So in this case, if I gave you $700 today and you were able to invest at 10%, as Leslie noted, you go 10%, 770, 10%, 847, 10%, 931.70. So if I said I'm going to give you $935 in 3 years, or I'm going to give you $700 today and you invested at 10%, what answer do you want? The 935 in 3 years. You're like, don't give me the 700 today and let me invest it at 10%, because the 935 is going to give me, I'm going to get a little bit more money. I'm going to make a grand total of $3.30 more.
That's only if you compound it. If you
Compounded.
Yeah, if you compound it.
Right.
You don't compound it, it's different, slightly different.
Here's your first formula. The future value of any given value, or of any given dollar amount, and N is the period. So the future value at period N, in this case at period 3, is going to be the present value, in this case 700, times 1 plus the interest rate, in this case 10%, so 1.1, to the N power, to the third power. Can anyone explain to me why this is 1 plus the interest rate? Right. If you just multiply this by the interest rate, it's going to go, and again, in Excel, this will blow up. You'll go 700 times 10% is 70. And that's not going to work. You want this, you're going to have 770, not just 70. If you just multiply it by the interest rate, you're only going to see the interest piece. So 1 plus the interest rate is the compounding. And why do we do it to the third power, to the n power? That's the number of periods, and that's the compounding piece. There's 2 types of interest. Simplistically, 2 types of interest. There's compound interest and simple interest. In the case of compound interest, which is what this formula is giving you, it looks like this. 700 times 10% is 770. 770 times 10% is 847. 847 times 10%, or 1.1, it's 931.70. If we were simple interest, it would be 700 times 10% is 770. 700 times 10% plus 770 is 840. 840, or 700 times 10% is 70, plus 840 gives you 927. 927, 920. So you lose $11. You normally don't get simple interest in this class. Yes, sir.
So, well, that's an easy enough thing to grasp. Wouldn't you also take into account the amount of time it takes you to find anything that's going to pay you 10%? Like,
You would know. That should all be, but where would you factor that in? The opportunity cost. It's factored into the interest. It's part of the risk of not being able to find something, the risk of sitting on money and not being able to reinvest it. There's reinvestment risk. We'll talk about that. There's 4 general ways to solve time value money problems. Use a cash flow timeline and calculate it by hand. Use an equation. Use a financial calculator. How many of you have ever seen a financial calculator? 1, 2, 3. You guys own a financial calculator? Oh, God bless you. Okay.
This is different than a 10 key.
Oh, this is different than a 10 key. I'll show you because I'm ancient and have done this for a long time. This is a financial calculator. This is a classic HP 12 financial calculator, which 10 years ago, if you didn't have one and you were a finance guy or gal, you really were harassed mercilessly because this was the reverse Polish notation RPN calculator of record. No one uses it anymore, and I actually had to dig this out for my other class so that people could see it, what one of those things looked like, and I probably have forgotten how to use a bulk of the functions. Or use a spreadsheet. We're going to focus on this last one. If you guys want to use any of these other things, you go ahead. We're going to focus on spreadsheets because the whole world uses spreadsheets, and they're a good tool. What, spreadsheets? Financial calculators? Yeah, financial calculators. You can. I've got one on my iPad, but I still would prefer to use Excel. And the main reason for it, as you'll see when we build out the Excel on Monday, is I strongly recommend you build out the table of each of the components. You essentially build templates to solve these things. You could search in Google and find templates out on the interwebs that will go, oh, I want to calculate a loan. I want to calculate a present value. I want to calculate a future value. You could go download spreadsheets that you can just plug the numbers in and it'll spit it out. The how to do the formula isn't that hard. The hard part, as I mentioned, is to really be able to take one of these word problems and pull it apart and go, okay, this piece goes here, this piece goes here, beginning of the period, end of the period, and be able to pick up the differences. These 3 websites, you can find them out on the Moodle site as well, are 3 that have free or very low cost Excel tutorials in them that get into some advanced things, more than you'd need for this class. But excuse me, as I mentioned, one of the key advantages to being here at St. Martin's is you have some Excel gurus, Dr. Conant. If you haven't had Dr. Conant yet, try and sneak in a couple of his classes. Get to know Excel because it's going to be your primary tool when you get out of school. in business. It is what we use to be able to function. So we're going to walk through this future value calculation. Here it is from an equation perspective. You plug in the 700, which is the present value, the 10%, which is the interest rate plus 1, to the third power, gives you 931.70. You're going to get the same answer every time. If you use a financial calculator, N is going to be your number of periods. This is I over Y. What do you think I over Y means? Interest rate over the years. What happens if it's compounded monthly? 36, and what would this number be? Say again? It'd be 0.833. So this is really 1 over N. So it's the interest rate divided by the number of periods, or divided by the compounding period. So if you have an interest rate expressed as an annual percentage rate, 10%, and they say it's compounded monthly, you need to divide it by 12. They say it's compounded quarterly, you need to divide it by 4. And then you need to multiply your number of N. It's 3 years compounded monthly, it'd be 36. This is your present value. It goes in, same with Excel, goes in as a negative number, negative 700. Why do you think it's negative? Exactly. The concept here, and it's a difficult concept to get your head around, is you go, well, it's $700, so I put in 700. You put in negative 700 in both your Excel formula as well as the financial calculator, because you're going, I'm paying $700 out now to get some expected future value back. So it's a $700 expense out today to get $931.70 back in the future. The PMT, what do you think that stands for? Payment. Annuity payments. So what you can also calculate here is go, I started with $700, it's 3 years at 10%, I'm going to add $100 a year to it with my future value. And then you hit future value to solve, and it'll pop up 931.70. The reason I walk through this in this level of detail is because when you do it in a spreadsheet, it's going to essentially have the same components, but you're just going to lay it out on a spreadsheet instead. You set up a table. Most of us go through our lives not showing our work. We go, okay, I'm going to just jam this thing out on a calculator. I'm just going to jam this thing out in the corner. I'm just going to write it on the back of an envelope. And then I'm going to go, it was X. If you're in accounting, in particular, you have to show your work because it's going to get audited. If you're in this class, I would show your work because it helps your grade, because you'll get partial credit. If you're working in the real world, show your work because likely someone else is going to be reviewing your work and or you're going to be presenting your work, and at least you want to be able to walk through it. So set up the table with each of the components. The other thing that you'll find, less in class, more in reality, is folks who go, well, what if I could get at 10.5%? What's the answer? Or what if instead of 700, I take $100 and I go out and buy something with it now. So I'm only going to have $600. What's going to be the answer? If you set it up in a table in Excel, you just make a couple changes to those parameters, or you use the scenario piece in Excel, and you can look at each of the components separately. Click F of X. So this is the function button in Excel. You go to the function tab, and you'll see financial functions, and choose the future value function. Click the cells containing the appropriate data to enter the data in the future value function and calculate the answer. We're going to walk through this on Monday. I'll show you what it looks like, but it's a walkthrough on Monday. This problem is set up in Excel the way I would want you to set it up going forward. N, number of periods is 3. I over Y, interest rate is 10%. Present value, again, negative 700. So just like with the financial calculator, you're gonna use a negative. Payment is zero because we have no intervening payments between the first payment of $700 and getting our $931.70 back at the end. Payment type, 0 or 1. Beginning of the period, which is ordinary, or an annuity due, which means it's delayed, and a 931.70. Under almost all circumstances, the default is a 0, an ordinary annuity. You'll see generally this in the question. You'll see it's an annuity due, or the payment's being made at the beginning of the period, or the payment's being made at the end of the period. You need to know whether that's an annuity due or a regular annuity, and whether it's a 1 or a 0. And then you've got a formula which says future value equals B2, B1, B3, B4, B5 equals X. And it solves for 931.70. If you then wanted to change the interest rate to 8%, all you do is change this to 8% here, 0.08, and it'll change this number. It'll flow all the way down. And so you can make easy changes to the spreadsheet to be able to do calculations. Once you build, what I've done historically, what I've got here at the university, is I've got an Excel spreadsheet that's basically called X Financial Calculator, and I've got different tabs for things like future value, present value, amortization table. You build it once, use it over and over and over again. Then you can save it somewhere else. And I would recommend for this class, you build those things out, because it'll be useful not only for all the homework, not only for the midterm, but for the final exam. And you're not going to have to be building spreadsheets on the fly. So future value of an annuity. So let's say I'm going to give you payments, and I'm going to give you payments over time. Equal amounts. I'm going to give you $100 a month for the next 5 years. An ordinary annuity says, I'm going to give you $100 a month starting the beginning of next month, and it's going to continue for 5 years. An annuity due says, I'm going to give you $100 a month starting today for the next 5 years. What do you think the difference is? 1 month. Which one do you think is more valuable? The annuity due. Why? You earn interest the first month. You get the money faster and you earn interest the first month. So here's again a timeline calculation, starting with 3-year ordinary annuity at $400 at 5%. So that means you're getting 3 payments at the end of each period, ordinary annuity. So period 1, you get a payment. Period 2, you get a payment. Period 3, you get a payment. Let's walk through a little. It looks pretty similar to the last equation. You've got this compounding interest equation. See, the 5% is in here. And this is 2 periods. 1, 2 periods of compounding, 1 period of compounding, and 0 periods of compounding. It's easier when you draw out the timeline to see how the math works. What's anything to the 0 power? 1. So 400 times 1 is 400. So that last period, that last piece of money that you get, that last payment of $400, the future value at that period of time is $400. You haven't had a chance to invest it. This second payment you receive, $400, you got to invest it for a year, from year to year, at 5%. So you multiply by 1.05, and the future value at the end of year 3 is what? 420. This first period, $400, 5%. You got to invest at 5% for 1 year, 5% for 2 years, compounded, it's worth $441. You add the 3 of those things together, your present value is $1,261. So you got $1,200 of payments, 400, 400, 400, and $61 of interest. Does that make sense? These can get many, many years and very, very long. And so drawing them out by lines doesn't necessarily help. That's where we get into formulas. The formula for future value of an annuity, and again, I'll walk through it briefly. The payment amount, $400. 1 plus R, what's R? Interest rate to the, which is number of periods, minus 1. Why minus 1?
Because you're getting that, beginning versus the end.
Because you're getting it at the end versus the beginning. So you don't get you lose a compounding period. That 1.05 to the 0, remember that? That's why you have the -1. If this was an annuity due, there's no -1 over the rate. And again, this is, you can calculate them this way. When they get really long, those lines are very difficult to calculate by line. So you can calculate them this way. In this particular case, you got a $400 payment. Oops, I got a decimal point missing. 1.05 to the third minus 1 over the rate as expressed in terms of decimals. So we're now at 3.1525 times 400, $1,261. The only time the formula becomes really handy is when you're trying to stretch out 50 periods, 60 periods, 75 periods. You can't do it by timeline. Here's the difference with the annuity due. You see you got this one extra period of compounding. So this first payment comes in day 1. 1.05 times 2 plus 1 point, or times 1.05. You got an extra period of compounding in each one of these. So you got 420, 441, 460, 305. You pick up an extra couple bucks. And you can see in this particular case, you can multiply by 1 plus R at the end. You can remove the -1, but you use the 1 plus R at the end. Follow that equation, and that gives you your annuity due. Cash flow streams. The payment designates a constant cash flow, the annuity stream. If you have a cash flow CF, and you'll see cash flows in the formulas, that's any cash flow, constant cash flow, annuity, payment, EMT, or uneven cash flows. So when you see the words cash flow, when you see payment, it's a payment, it's going to be an annuity. When you see cash flows, check and see if those cash flows are changing over time, because you have to design the equation differently in order to be able to solve. And here you can see, and we'll leave with this example. Here you can see uneven cash flows. You say, okay, we're going to make 3 payments at the end of each period. At the end of the first year, you're getting $400. The end of the second year, you're getting $300. The end of the third year, you're getting $250. What's the future value of that at 5%? It's the same, when you're looking at the timeline, it's the same math. Multiply this, multiply this, multiply this, add it up, and it sums up. If these were reversed, so you got 250, 300, and 400, and you're looking at a future value, you think it's going to be higher or lower? So if this was 250, let's say 300, and that was 400, it's going to be lower. Why? Why?
250 or less than the 400 over the.
Yeah. Here you're compounding 400 twice, so you're going to earn more. If this was 250, you'd compound 250 twice, you'd earn less, and the 400 comes in at the end. Some of these, when you're looking at multiple choice questions, you should be able to pick out very quickly. Okay, that one can't be right, because if it reversed the cash flow, it can't be a higher number. It needs to be a lower number. You can eliminate some of your questions. For the future value of a cash flow, you take your cash flow at time t times 1 plus r, the rate, n minus t, number of periods minus the period you're measuring, and you sum all those up. That's sum from 1 to the nth. There's no real good shortcut to be able to come up with future value of uneven cash flows. That's what it looks like. I'm going to leave it there. We'll dive into present values on Monday, and we'll also do some Excel problems on Monday. If we need to slow down here in chapter 4 and 5 so that we get a good grasp of what's going on, we'll do so, because this is foundational for the rest of the course. If you have any questions, come see me.
So I will be here February 9th through the 19th.
Okay.
Baseball's going.
Oh, yes, I heard from Coach Garland. How lucky you guys are.